Hi guys, welcome back. Last time we just finished the measurement of ATR FTIR spectroscopy of serum sample. This is the spectral data which we got by measuring the serum sample. Okay, yeah, as I mentioned, this peak mainly represent the water content. So as the water dries, the height of the peak goes down, and like it is like the stable dispositions. Okay, and this region represent the protein region. So as the water dries, then the interaction of light with protein becomes more, so it goes up. As the time increases, it goes up. This pink line was the, I think it is the first measurement. And in the down one you can see this is the background, so this should be subtracted from the original spectra. So that our spectra are after subtracting background. If you remember, in the measurement I subtracted the background. Okay, sorry, the battery is finishing my phone. So in this video I will show how to do the data analysis if the battery remains for the long time. Yeah, so in the protocol I mentioned that we choose last 6 which are best reproducible. So actually the serum sample may have been our spectral measurement may be stabilized after stable, that is reproducible after maybe 10th spectra, or you can play with that. Study shows that after 8 minutes or after 10 minutes you can get the reproducible by measuring the serum. But today I am not using the fresh sample, it was the waste sample, and I didn't put inside the freeze for a long time, so it may have taken the different times. So to avoid any confusion, I just select the spectral 24. So I have to click control 24, 23, 22, 21, 20, 19, 1, 2, 3, 4, 5, 6, 6 data. Yeah, I just selected them because these are the last one, and I just open the new page. If you click here, then you can get the new page, and put the selected data here so that I can highlight this. If you look at them, everything is overlapping here. So these are exactly like one above the other. Okay, so for the spectral analysis we have to take the average of the 6. Let's to average of this one, you can select again control and select all, and again click the new page, so that new page, and click the manipulate. Have you seen averaging somewhere? Averaging. So that means there are 6 spectra counting from number 19 to number 24. So there are 6. So if I click I select all them and go to manipulate, open the new page, and then select averaging. There are different options: update average spectrum, create update something different. So we have to do the weighting with the number of scans. So this is showing that like whatever you are using while averaging any mathematical quantities, so this is saying the same thing, the average. So this is the average spectra. Other averaging means people are averaging with the standard deviations by calculating something, but just a simple averaging. Okay, so this is the average spectra. You can magnify by this one. So I magnify this one. This is the magnified, so that you can see clearly. This is the average spectra. I will convert this into the Excel file and put into Excel folder, so that you can see the data with that spectral curve. So this is the original curve. Now we have to take the second derivative. So to take the second derivative, click here and go to manipulate, go to derivative, second derivative, number of smoothing points. The minimum value of number of smoothing point is 9, and the number of derivative, this is the gradient. 1 means first derivative means gradient, so we have to use the second derivative. You can do other also to learn. And number of smoothing point is 9. I will explain what is the importance in the PowerPoint later and do process. So this one is the second derivative, the down one, like this one is the second derivative. If you look at here, the first one is the observance curve and second one is the second derivative. So open the new page again, new page, and pull the second derivative curve there and then maximize. Now you can see the second derivative curve. Too much like a noise. So if I have not used the 9-point smoothing, so it will be like the crowd, we cannot distinguish. That's why we need the smoothing for the second derivative curve. So this is the second derivative curve and this is the observance curve, and second derivative is down, very small value because the gradient is very small, yeah. So that's the second derivative is here. So to make it more, so I put in the new page. So to highlight this one from 18 to 900 region, you can select the only this region. So this will be the second derivative curve. Okay, so you can save the second derivative curve. After obtaining second derivative curve, generally we don't need the second derivative curve. Generally people do the vector normalization of second derivative curve. I'll discuss why it is important to do the vector normalization in the PowerPoint slide. After that, I'll make a PowerPoint slide of every step by explaining my understanding on that. So, and I'll put the Excel file by step, and all the things you will get this one here. Sorry, there is a common folder for all the students who is in this lab. It is called the L drive. If you go to computer, then you can see system DVD RAM UP lab on physics server. This is L folder. Okay, go to L drive, then here just go to Hemendra. Yes, this you can see Hemendra. This is my folder, down one is my folder, and upper one is the thesis material. So I will include all the discussion in this thesis material. So I will include everything here. So ATR FTR spectra of serum sample, I will explain all the steps in the subfolder. All the files which I use in my thesis, everything will be here. You can get all the information. So I will put a PowerPoint slide by saying the like instruction something. So you will get step by step in the PowerPoint. So this is the vector normalized data. So select this one. We have to do the vector normalizations. You have to also study what is meant by normalization. Why do you need? Otherwise, it will like be the spoon feeding. You have to, if you explore yourself, then it will be. Generally, normalizations. You select the 900 to 1800. We have to do the vector normalization for the second derivative. Normalize and go to this one, so that these are the vector normalized second derivative, and save into folder. To save this one, select this one, go to file, save file is path. Okay, just change the path. So let's go to L drive, go to earlier for yes, this is not me, this is my folder, and this is thesis material ATR FTR. So yeah, just save here. Later on you can save in the different folder. Okay, go to the, give the different name, 2ND. This is second derivative, so I saved only the vector normalized, and then save. And remember, while saving, all the data files should be data point table. Otherwise, if you save into different format, you cannot convert into Excel file. I don't know how to convert. I don't know. There may be other techniques, but I know only how to convert DPT file. Save. Now it is saved here. I'll delete this immediately because I don't need to save this one. I have to put all the steps in detail. So this is the second derivative curve, and we don't need any second derivative curve anymore. I will use that later. So go back here. This is the observance curve and the second derivative curve. So go back. we don't need second derivative, undo. So you got the only observation score, and we don't need the second page, just a delete. And we have, for the observation score, we have to do maximum minimum normalizations. Select the observation score, go to manipulate. Where is normalizations? Frequency range is same, min max normalizations. I'll explain why do we need to do that. Normalize up to 2. Look at this, the MI at first peak is at 2 value, the observance value at MI at first peak. The program does like this one. Okay, then you can compare the normalized values. Suppose this is the spectral data of one sample. Then if you have so many samples, suppose 20 control sample, you will get the 20 spectra, normalized spectra of control sample, and 20 disease sample. So you can compare the 20 disease versus 20 control by using, first of all, I am comparing by using the p-value calculations, student t-test p-value calculation. So here it is just the one spectra, so I will explain the p-value calculation in the PowerPoint, or I will make another video if you need. So this is the one spectra. Similarly, you can get hundreds of spectra by measuring hundreds of sample. This is, I think, the step is same for all the samples. And let's do the cut and other things. Let's try to do fit. So to select this one, to do the fitting, select this one, go to manipulate again, cut, and frequency range is 16 to 1700. Let's do the MI first fitting, cut. So it will just select only this region, and do manipulate, baseline correction. Select the method. There are different options: scattering correction, concave rubber band correction, rubber band correction. We just do the rubber band correction. I will explain why and everything. I will try to explain. I don't know the detail, but I will explain as much as I know. Correct, and then maximize. Yeah, this is the rubber band corrected graph, and now it is saved. So to do the fitting, go to evaluate, core fit. Frequency range is last time I changed, it should be 1600 to 1700. 1600 to 1700. Core fit. If you click the save signal fix to, then you can save all the information after fitting. So don't click fit, click the start interactive mode. You will get such information. And then if you look at the second derivative spectra in detail from 1600 to 1700, you will see 5 number of minima. But study shows, and so many of our collaborator, reviewer of our paper, and this suggests that there should be 6 minima. And the selection of number of minima, selection of the Gaussian bands should follow the some signs, some studies. So I found that there should be 6 number of Gaussian bands to fit this energy band, and I know that one should be here, one should be nearly here, one should be here, one should be small should be here, and 2 should be here. And you get all the information here, and this should be Gaussian. People call Gaussian or Gaussian something. Normal distribution, whatever, if you don't understand the Gaussian, normal distribution. All the science, all the statistics should follow the normal distribution. So molecular vibration also follow the normal distribution. But if there is a overlap of vibration, if you are doing the fitting without the rubber band correction, then you have to do the Lorentzian distribution. So I just unselect the position, because this position are I can approximate from my earlier study, and then auto fit, it will fit. This one is 0. Yes, program does not support every time, because the spectral data is sometime So you can play with that program, okay, by changing the position, by changing the intensity. So this is your duty. Okay, there are few. Now play with that for a little bit time. Okay. Still this is not working, so 0. The position should be approximate to the information you got from the minima of second derivative curve. Look at here, one is nearly there, another one, this is beta, this is side chain, beta sheet, alpha helix if you have read the paper, and there are the other distributions. Okay, so you got all the distributions and which are approximated from the second derivative minima, and everything is fine. And if you look, the method is Levenberg fitting, and this is 0.0035. Yeah, as I mentioned earlier, for almost this colitis sample study, this is the just waste sample, but for other sample you will get 0.0035 for almost all the samples, and save peaks, and you can save so that you can get information later. These are the fit values. So if you click this one, sorry, and then right click, show report. Yeah, these are the information. Look at here, all the information are here. What is the RMS error, what is the integral values. So I just take the integral values, and because alpha to beta integral is more, and divide alpha and beta, and then do the statistical analysis. Yeah, this is the fitting. These are the techniques. Today while recording this video, I found that my voice is not like irritating. It is not clear, and it is not pleasant to listen, so I'm sorry for that. Otherwise I try to help you guys. Even if it is irritating, just to try to listen, or you can mute the video and try to see the steps. Okay, and then that will be helpful for you guys. Okay, thank you guys for watching. If you have any question, just you can ask me, or you can ask to Dr. Pereira. Then if Dr. Pereira asks me to do, then I can help you guys. Thank you.